Western civilization is moving closer to a point of irreconcilable, unstable equilibrium, as frighteningly increasing numbers of people trust nothing. Media, academia, and especially the governments are no longer held in high esteem. Regaining trust is often impossible after betrayal. However, transparency is essential to any healing process, and that is the essence of the Don Sullivan Show. Please listen to the team explore, probe, and debate cutting-edge science, technology, and computing. Play ball! Once again, welcome back everyone to the Don Sullivan Show, the show where we discuss all things science, technology, and computing on a level that can be absorbed and understood and utilized, hopefully, by your average American teenager. And by American, I mean Western civilization as a whole. Today, we are going to have a very interesting discussion. We're really going to get into the computing world. And our guest, Fredrick Van Haren, is a friend of mine from a while back who has been recommended very highly to be on this show to extend our conversations about computing and artificial intelligence in very specific areas. One of the important aspects of where we're going in these particular shows and all of these specific streamlines of the shows is that we've had a basis for theoretical and just the ideas of artificial intelligence computing. But now we're really going to get into some of the nitty gritty, the real meat of it all. And that is when people actually put themselves on the line and start companies. Now there's hundreds of companies out there or hundreds of startups in Silicon Valley and or throughout the world. But there are a few that are actually making it, and this is one of them. So Frederic is the CTO and one of the founders of HighFens, and we are going to talk to Frederic about all of this. Again, we're fortunate to have him on. He is a true Silicon Valley pioneer. As a global pioneer, Frederic has studied all over the world in prestigious institutions such as KU Leuven, the oldest university in Belgium. He's the founder of HighFens. It's an AI consulting and speech recognition tech company. His podcast, the Tech Field Day podcast, focuses on AI. Frederic and I first met at the VMware Experts program. It was a program that I ran for 10 years at VMware. We had 4 different branches, and it was the big data branch. And we're going to talk about the evolution of the languages, since this is a speech recognition subject. But big data and HPC certainly led off into machine learning and what is now the buzzword from 50 years ago, as Pat Gelsinger referred to it, AI or artificial intelligence is a 50-year overnight success story, but it's really all about the arithmetic behind machine learning. Gina and I talked about that in previous episodes, but we're going to talk more about it here in terms of the actual productization. Frederic is in Boston now. I'll forgive him that. Frederic, you have to understand that we always have baseball nuances in this show, and the more things change, the more they remain Yankees, Red Sox. So I'm a New Jersey, New York Yankee guy, and you're in Boston, and you might not know all of that necessarily, but there's these right now it's about basketball, right, Stephen? Basketball between the Knicks and the Boston. But the Yankees and Red Sox will be at the center of it all, as they always are. So we'll forgive Frederic for that at the moment. But first, at our lawyer's insistence, before we get moving on and allow Frederic to introduce himself, our lawyers need us to, in every show, me to read out the disclaimer. So all statements by the host and the guests of the Don Sullivan Show are the personal opinions of the host and the guests, all who agree that the following content is the property of Xanalytics LLC to be publicly and exclusively used on the Don Sullivan Show. So the audience can't see it because this is an audio-only podcast, but everybody's shaking their heads so we can move on, and everybody's happy about that. So, Frederic, say hello and introduce yourself, and then I'll have Stephen as well.
Well, first of all, thank you for having me. So my name is Fredrick Van Haren, and as Don said, so I live in Boston, but I grew up in Europe, so maybe I get some extra credit for that.
You do, definitely.
And very happy to be here.
Your name is also very close to Van Halen, so that's extra credit as well.
I
in
don't
my
know if
opinion,
David Lee Roth is going to make an appearance here, or Eddie is not with us anymore. But yeah.
Well, funny story. Yeah, funny story there. When my kids were younger, I would actually say that our name was that Van Haren is difficult to pronounce in Asia because they don't pronounce the R. So our real name is Van Halen. So my kids for a while believed that we're really related to the Van Halens.
That's fantastic.
Top 10 guitarist of all time
on
the
up
Don
there.
Sullivan Show.
I love a little Panama Dreams. Yeah, that quite a collection of songs they had.
All right, Jersey Steve, relax now. No, we're not going to have any of the rock stars on at the moment, but we might eventually. Sadhir's going to come on later to talk about some later show to talk about heavy metal, but not now. Today we're talking about AI and speech recognition and how companies actually develop. And Fredrick has HighFens, which again is a legitimate AI startup, and there are many of them, but most of them aren't making it. Some of them are going to. And we're going to have him on hopefully a bunch of times to talk about all of this. But I want to start off this discussion with a number of different questions. And we've had, Frederick, a number of people on to talk about machine learning and artificial intelligence. But again, we've never had anybody who has actually taken that next step to actually start a company. And you've done that a few times in your career. But right now we've got HighFens. A lot of AI startups are in Silicon Valley, but I'd love to start this conversation off with, after introducing you, to talk to the audience about HighFens. And as you are the CTO of the company and a founder, tell us about HighFens to start off this conversation, if you can.
Yeah, maybe let's level set a little bit about my background. So my background is indeed speech technologies such as text-to-speech, speech recognition, and also speaker verification. Sometimes a lot of people forget about speaker verification. So speaker verification is to be able to identify a speaker from another speaker. So I did that for a company called Nuance Communications, which you could be considered as ground zero for modern speech recognition. And so what did I do there? I was part of an R&D organization, and in 2006, I was called into the office of the CEO, who basically said, "We're going to take away all your research groups, and we're going to do something with data." It sounded more like a layoff or an exit conversation than a promise to something new. A little bit of a fast forward. So we built large clusters. In the beginning, it was more HPC. So it was about 115 racks of equipment serving 800 researchers. And so the main goal was building language models for languages across the world. So your audience might be interested. Some of the projects we worked on, the biggest known is Siri, Apple Siri. Every time you use Siri, you can think of us.
That's a pretty household name, Frederick.
It is. It's the number one use case I always bring up. It helps a lot to kind of settle the conversation. And then there were other products like Dragon Naturally Speaking, which are kind of commercial products you can install on a laptop or a server. And then speech in cars, right? You will see that speech in cars is evolving really rapidly. So we worked on German cars, Japanese cars, and so on. So why would I leave, right? Why would I go somewhere else if it's so much fun and so interesting? Well, the challenge is that AI innovation goes so fast that sometimes you're willing to take a different route. And in my case, in 2016, I decided that I build up a lot of AI expertise, going from HPC to AI, going from compute-centric to data-centric, and certainly having worked on large projects, I built up a decent amount of expertise that I wanted to share with the community and with other organizations. And so in 2016, a lot of the hardware vendors came to me and said, "Hey, can you help us kind of set a hardware portfolio for AI?" Because in 2016, a lot of the hardware vendors were basically trying to sell you the biggest and the meanest devices they had because they assumed that the complexity of AI meant that they had to sell you very large devices.
They have a motivation to do that as well. Of course, they want to sell you as much as possible.
Indeed. The problem is that AI is more like a modular design. And so the way you can think about it is a traditional corporate IT solution. You would buy it, you would use it for 3 years, and then you would buy something else. What we learned with AI is that innovation cycle is significantly accelerated. And so we saw during the nuance days that we would double in capacity every 12 to 18 months, which is quite challenging because it basically means you're continuously in a mode of growing from an infrastructure perspective, also from a workload perspective. And at the same time, because you're being successful, you add a lot of data sources.
Well, I would even say that now that's accelerated. That's actually conservative. When you look at the situations like we know about Stargate now, they literally are building a single computer the size of a stadium. And that's the only way to put it. And so, I mean, that's about the number of GPUs in that project that they're going to put $500 billion into. Musk doesn't think they have it, but it's Larry, so he does. So.
Right. Yeah, and then the architectures also changed, right? So for CPUs, you typically use a northwest architecture, while for accelerated computing like FPGAs and GPUs, you needed like an east-west architecture. So what does that mean? It means that you can't use the traditional network switches because they have oversubscription, while in east-west, you cannot have oversubscription. Your storage is different, as well as your compute, right? You're using GPUs and others. So as I mentioned, HighFens in 2016, I started working with hardware vendors. Today, there's 3 main things we do. So the first one is consulting. And so consulting can go working with hardware vendors. So even today, we do NDA work, non-disclosure agreement work, which basically means we're kind of working on products of the future. And then hardware vendors look at, how those devices need to be built, and then they bring it to the market like in a year or two. We also do consulting with end users. What's an end user? It can be an enterprise at any level of AI maturity. It could be somebody saying, I have a pile of data. What do I do with it? Or it could somebody say, we have a bunch of great ideas, but we don't have the data. We don't have the infrastructure. So consulting
is really... The end user could be a device these days too, right?
It could be, definitely. Yes, it definitely could. And then you have services. You can look at services as hands-on, right? So all of the hardware can be very complex. A company might be in a situation where they acquired hardware and the hardware is not efficiently configured, and they might consult us and ask us to do some services. And then finally, we do AI solutions. So what's an AI solution? It's the whole thing. It's from the beginning till the end, where we also do the reselling. And so reselling, although it sounds easy, you just buy some boxes from hardware vendors and then you have somebody put it together. All of these components, compute, network, and storage, are very neatly tied together. And if it's not, then you spend a lot of money for not a lot of productivity.
Right, and that makes complete sense given how you described the problem with the over allocation or oversubscription. It is so pervasive throughout the industry, whether or not it's just an administrator allocating too much by way of resources, or an account team telling you to buy everything that they've got on a truck.
Right.
And you are going to be so much more focused on the solution that is best for the customer. It completely makes sense that they, or whoever that customer is, work with you directly, as opposed to the more classic methodologies of going the big vendor route and then eventually getting down to somebody who knows what they're doing.
Right. And it's also important to kind of split AI in its 2 components, right? So when you talk about AI, and I'm oversimplifying here a little bit, but there are really two components, right? There is the training component, and then the inference, which is a fancy word for, production. And so what happens in training? In training, you have a pile of data and you're trying to make sense of it. And it takes a lot of hardware and a lot of time to build an AI model. And then once you have that model, you can put it in production, but it doesn't stop there, right? AI is all about continuous learning. So every time you use a model in production, it generates another set of data. And so that set of data is then being fed back to the source. So you can imagine it's like a vicious circle, right? And so the challenge for successful AI companies is that if they're really successful, they will generate a significant amount of data.
Well, right? They're staying ahead of the next model as well, and they're building on top of the next model or all the other models that are out there. It's just self-perpetuating into infinitum.
Yeah, but except that if you double the amount of data you have and you want your models to be generated in the same amount of time, you have to buy more than double the amount of hardware, right? So
this is the reason for stadium-sized computers, whether it's this monstrosity outside of Las Vegas in Nevada that's storing everything that's ever been referenced on the internet, or it's Stargate or whatever is coming next. And again, we're going to eventually get into quantum computing, which is a lot, obviously, many, many orders of magnitude beyond what we're even at right now in terms of the analysis and the development, rather than just mathematical, massive iteration and interpolation through extremely science fiction level processors like DPUs and GPUs and IPUs and, well, whatever else is coming next.
We had a podcast on those not too long ago.
We had Tony
Fredrick,
Foster on talking about them. Yeah.
Just out of curiosity, are there any concerns about AI? Basically, the more AI is used and gobbles up data, the more data it creates. And then there's just a lot of AI generated data and content out there. Are there any concerns that there could be a tipping point where most of the content that new AI models are learning on is just AI generated content and it's passing along potential biases or things like that?
Yeah, I mean, biases and others is always a concern. I mean, even us humans, we deal with bad data, right? So we get bad data all day, and the definition of bad data depends on how you think about certain things. So
turn on the television, you have bad data, right? So
right. And so yes. So I think there's a heavy focus on kind of helping that. So today, large language models, you can download them from Facebook/Meta or Google and others or OpenAI. And so that's kind of a black box to you. You really don't know what's happening. The next generation is basically using large language models, but add some reasoning to it, right? And the idea behind reasoning is to give it a more human-like approach. And again, it doesn't mean that the answer will be correct. It just means that the approach to handling the data is similar to how you and I approach the data.
We're getting closer to legitimate neural networks in terms of how a brain works, getting closer to it at least, even though it's still about arithmetic more than anything, an iteration.
Right. I mean, there's no secret that AI is all about math, right? So we can do a deep dive about data. But what typically neural networks are trying to do is it's given a data set and then it's trying to find relationships between those data sets. And so what happens in a training session is weights are being assigned to the values of those relations. And so data points that are insignificant or considered insignificant from a relationship perspective will get a low weight, while others that have a high relationship will be assigned a larger weight. And so that's really what's happening in training. And in production, you're taking all your math models and you fill in those weights you calculated in training. So that's why training while production goes a lot faster, because you're not trying to find something out. You're filling in those weights in formulas and you get results. But it's all math, right? Like I said, we can have conversations about that.
We do all the time here, and it's, I mean, honestly, I don't mean to be flippant or even dismissive about it, but math almost seems to be too sophisticated. It's arithmetic in that sense. It's interpolation, extrapolation. It's it's arithmetic, and it's a lot of it, but it's a lot. It still is.
Right. It has to be said that not all data is ideal for AI, right? So the best way to describe it is that when you feed data to a training model, there has to be a relationship between your data points, right? Because that's exactly what the math is trying to do, is to figure out the weak and the strong relationships such that when you ask a question, it can look at those relationships. If you, for example, would generate random numbers or random data sets with absolutely no relationship, the math will try to find relationships, right? But what you basically did then is you build a random generator. The problem is when you're given a large language model that is based on random data, you have no idea that the outcome is really random, right?
Like Mad Libs.
Right. And that's a big concern, right? So a big thing nowadays with large language models is the ability to find out what data was used to build the large language model. If you look at the old days where you had an executable, the executable is a binary. There's no way for you to figure out what source code was used in order to build the executable, right?
Why data lineage is important. Yeah,
the data lineage,
explainability and transparency.
Right. And so you will
still
see
need an audit trail, basically.
Yeah, it's an audit trail, and you will see that nowadays, in order to address, the concerns about bias, is that you're building models that actually check models. They interrogate the models to figure out how that model responds to you in certain areas, right? And then you
There's
can
a circular logic with it that actually comes out with a much more pertinent set of results in terms of its own, as you just said, self-interrogation. That is amazing. This is something we haven't really discussed here, Steve.
Yeah, we touched upon RAG, Retrieval Augmented Generation, but that's to what's the word? Damper the models.
Yeah, so RAG stands for Retrieve, Augment, Generate. And so basically what it means is when you download a large language model, and let's say that large language model, ChatGPT 3.0 or so, from let's say 2 years ago. And so since that large language model was last touched 2 years ago, that for any data that has been generated in the last 2 years, if you ask about sports events and so on, it might give you an answer, but that data is missing. And so RAG is a way to introduce or data domain specific data, right? Data that's not in the existing large language model. So when I do presentations, what I do is I use Lego as an example. And so, the demo I'm showing is I download a large language model from OpenAI, and I ask about the latest Lego products from the catalog. And of course, a large language model says, well, here's what I have. And what I can do with RAG is I can load the Lego catalog fully and present it next to the large language model. And when a prompt comes in, for example, give me the latest or give me the best-selling Lego products, I'm going to retrieve, the R in RAG, I'm going to retrieve that information from the Lego database I provided it, which is also called a vector database. And that output, I'm going to provide it to the large language model. So I'm basically augmenting the large language model
with fact-based data.
With that information. And then the final G in RAG is now I'm generating an answer based on the retrieved information that I provided with a large language model, basically augmenting the input to the large language model. And then the large language model will generate an answer. So RAG is very, very popular to create or data domain specific, or if you want real-time data, right? So for example, if you build an application around stock pricing, you can have you can feed it continuous data through the RAG model, and such that you can build a stock price model that you can query with basically something you can run on your laptop.
But this is getting closer into the predictive AI models that are somewhat futuristic than even generative. And that's when the world is really going to change.
Right. It's you build on.
When you start talking about stock pricing or predicting sports, then you're in a whole different realm of.
Don wants to make some money. He wants a sports prediction machine.
Well, the problem is not predicting, right? So the thing with a large language model is it always will have an answer for you, no matter what. The challenge is,
you're getting into a stock analysis. You are getting into prediction, though, aren't you? That's what people expect whenever they have that. Whenever that part of the discussion comes up, they want advice. They don't want to actually have to think about it or make judgments or guesses.
Prescriptive, yeah.
And that's where. That's where agentic comes into play, right? Agentic AI is basically building on top of that and providing your answers. But even if you look at the stock market, I mean, not to turn this into politics, but political decisions.
Things that are not predictable that'll happen every day.
Right.
Obviously, we have somebody in charge of Western civilization at the moment who can, at any particular moment, say anything interesting, even if he's just playing games with people, that would change everything, for that day.
Right. So predictive works the best if your data is cyclic, right? If there is a trend and the trend recurs often, like weather, right? Like seasons. That a lot of the weather reports are cyclic, and so the predictive analysis coming out of a weather application is a lot more reliable than a stock market, for example.
But it has human behavior involved in it, which again, you go back to, that's the real problem with automatic driving cars is not the car itself, it's the other people on the road.
Right. And, and that's an interesting question, right? So, I mean, the question I get all the time is, when will, self-driving cars be safer than a human driving? And then my answer to that is, or my response,
when you get rid of humans.
Well, it depends, right? I mean, there are bad drivers, there are good drivers, but I would prefer a self-driving car than a teenager that's on drugs and drunk, right?
I would probably take a Waymo over a drunk teenager. I got to be honest.
Well, we're watching in San Francisco and in Las Vegas taxi cabs that don't have drivers, and they are doing just absolutely fine. We did see in early Pittsburgh 5 years ago, and they were running self-driving cars, that they did things like go down and run these streets that had just changed their one-way orientation and get that wrong and so on. But for the most part, again, like I said, there are safe drivers, and that's maybe 100 or 99 out of 100. But all you need is one to screw up everything.
Butterfly effect it,
The butterfly effect.
But you will always have that with
dominates. Yeah.
You will always have that with AI. I think what you can expect is that, or at least from my perspective, is if AI can do similar things than humans and have a better error rate, whatever they're doing, I would consider that an improvement. And that's what to strive for. I think seeking perfection is very, very difficult. And if somebody had figured out the stock market by now, to going back to the stock market, then that person wouldn't share what they have, right?
That's
they
a
would be.
great point. It's not like they'd have a press announcement. Hey, everybody! I figured out how to predict stocks with 100% accuracy. They're just going to make a lot of money.
Well, one of the mottos that I tend to have with AI and with the fear mongering around it, whether it's very high profile people or just people who are concerned about the everyday issues with faking of videos and pictures and so on, this is still all well understood, and that from whether we're going from predictive or from generative to predictive to something more, we really artificial intelligence is still, as we keep saying, mathematical iteration. At some point, when you really are able to simulate real neural networks, in other words, how the brain works in creating emotional synapses and therefore memory every single instant, then we're in a different realm. And then you're in the realm of artificial intuition. Call me when you get to artificial intuition as opposed to just
Here's what I think, Don.
intelligence.
The real peak will be when they can get self-driving cars to navigate the Garden State Parkway.
Yeah, well, I'm more concerned with the turnpike, but especially around Newark Airport.
If they can get it safe and smart enough to deal with that craziness,
did I just bash Newark
that'll
Airport?
Be something.
Newark Airport has had it rough over the last few weeks, so I should probably leave them alone there. But hey, Frederick, I would like to sort of get back to some of our other more mundane. This is incredibly fascinating, and like I said, we're hopefully going to be able to have you on a lot to really talk about this, but I'm really interested in what your thoughts are on the history of the actual language that we use. I mean, when we first met, the VMware Experts event was specifically a big data event. Now, that's a term that is almost relegated to the historic museums of Silicon Valley. It was big data and HPC was so much more focused on really just scientific computing. And now it still exists, but it's so much more pervasive throughout the entire industry. Big data is pretty much just, again, relegated completely to the historic realms. But
it's just data now.
Yeah, the machine learning has become artificial intelligence, which was, again, as Pat Gelsinger always described, a concept that was kind of stolen from cartoons from 50 years ago, and now a tremendous buzzword that is pervasive everywhere in any promotional entity that exists. So how did all of that happen, do you think? How did this language or the language that we use change? And did the technology really change that much? Or is it really all about the evolution of HPC, which I kind of think it is?
Well, first of all, who comes up with all these marketing terms, right?
Yeah, I was in product marketing, so I should shut up because my fault, maybe.
Well, you can look at it from another angle. So the reason why today we can do and build large language models, it's not because the algorithms are new, because the algorithms are relatively old. I mean, some of the algorithms in AI are from the 70s and the 80s, right? People realized that there was a way to do that. They just didn't have the compute power to do it. And explicitly say the compute power, because in the early and like mid 1900s to the early 2000s, it was all about compute, right? So HPC was in high performance computing. It's not high performance storage, it's high performance computing. So there was a heavy focus on the capabilities behind computing. And so the problems you were trying to solve with HPC was typically with servers with 1 socket, 2 sockets, 4 sockets, and even 8 sockets. Where do you see servers today in AI with 8 sockets? They don't, right? And that's because the world has changed. And it's changed to the point where the workloads are getting so big and so heavy on compute and data that the difficulty became clustering for HPC, right? So for example,
we sort of solved that with virtualization, so at least at the time. But and I don't mean to interrupt you here, but this is an incredibly important segue into your company and the companies of the future. In that, I bet my career, my life on the value of virtualization. But in the early days, it was all about consolidation and efficiency, and then it became about the abstraction and the ability to use it in every fashion and every possible application. And now it's evolving immensely, literally on a daily basis. And soon we're going to be in the realm of the realistic use of quantum computing. So go ahead, keep on going. But where is this transitioning?
Yeah, I think the abstraction layer, virtualization, I mean, it existed before VMware, right? Even mainframes had the concept.
It absolutely did. That's what MVS was, right? But it became commonplace and usable in the realm of x86 in 2000 or so.
Right. And I think there's always a need for kind of level of abstraction, because the underlying hardware shouldn't dictate too much the software on top of that, right? If it's so tightly coupled with the hardware, then none of us can run efficiently, right? Because every time there's a new server, everything breaks. So going from HPC to big data, I mean, to me, big data is really where the workloads became more data-centric, and it couldn't be handled by the traditional equipment available to people. Think about Hadoop, methodologies as MapReduce. I haven't
heard that term in a while, but yeah.
And hyperconverged. And so big data was big in those days. I wouldn't use the term big data today.
Nobody does. It's gone. Right. It's in a museum.
Assay.
Yeah.
Right.
People just refer to data.
Right. And I think that's important. But there was a time when Hadoop was really a viable solution for many organizations, including us. We looked at it as well. So nowadays, it's more about GPUs in combination with data. And so, Don, you brought up quantum computing. So quantum computing is making great improvements. I think one of the big challenges for quantum computing today is still the limited use cases. We will eventually get there, but even today, it is very challenging to deliver a quantum solution that works for multiple use cases. But we're getting there, no doubt.
You're getting there, but I wonder. I wonder how it's actually going to eventually be manifested within the productization of what, say, you're trying to do with speech recognition versus what the other hundreds of companies are trying to do. Is it really realistic, or is this something that is truly science fiction? And obviously the CEO of NVIDIA at GTC got himself in trouble when he mentioned that he thought, as I'm sort of espousing here, that it still was generations away from being realistic. Do you think it is? Or because we're talking about, theoretically, again, many orders of magnitude from a processing perspective. Now we have, we went and found how valuable video game cards could be, and that changed the world. And then other companies started creating DPUs and IPUs for different reasons, for utilizing the data and the infrastructure itself on single chips. But it's still GPUs are and NVIDIA is the most prominent as a single entity. And the quantum computing companies are taking in huge amounts of VC money for. And will they really be the next step? And is it near term, or is this still Star Trek generations away?
Yeah, I wouldn't say Star Trek generations away. I think the amount of applications that are interesting to the industry are very limited, and that's how most VCs and companies look at it, right? If there's no application for it, right, then it's not something that's feasible. But what quantum brings to the table is a problem that the GPUs have today, which is you have to generate faster and faster GPUs in order to address and process and train more and more data. It's a battle they're losing, right? In other
They're
words,
losing. You think
yeah,
they're losing this battle? That's
they're
okay. That's where I
indeed
really was
losing this
going with
battle,
that question. Okay.
right? And quantum is a shortcut, right? But the shortcut is not as easily productized for use cases as it is with GPUs, right? And to be fair, even GPUs today are not necessarily the right solution for your problem, right? There might be other processors that are better for you.
Well,
But from
I'll go back to 10 years ago where Josh Simons at VMware, back in the time, 8 years ago even, when he talked about there are certain solutions or certain situations in which the right configuration of classic CPUs and an HPC architecture has made more sense than GPUs. I never completely understood that, but just from a very simplistic raw power or speed perspective, but he was adamant about that.
Yeah, and it's true, right? It is definitely true. I think what NVIDIA is going through today is similar to Intel, a decade ago, which is if you have a problem that requires compute power, you used to buy Intel CPUs. If you have a problem to train your data, you buy GPUs. But the reality is there are GPUs and GPUs, right? You can buy the latest and greatest GPUs. There's no harm besides your wallet being hit significantly by buying the latest and greatest GPUs. But we sometimes provide
the
customers.
old adage: people never get fired for buying IBM. Now people don't get fired for buying GPUs and NVIDIA, but that'll change. Who knows?
Exactly. Yeah, but it definitely will change. I mean, if you look at workflow, so what's a workflow? A workflow is starts with getting data from different sources and cleaning it. You don't use GPUs for that. You use CPUs for that, right? And then down in the pipeline, when you're doing the heavy duty number crunching,
this is the efficiency of HighFens architectures and true solutions, as opposed to just buying the biggest and best of everything. I really appreciate that, and I think that really is something that is extremely important. And take me, I'm interrupting you here, but I'm promoting the value of HighFens in that respect.
Right, and I definitely appreciate that. I can give you an example. 2 years ago, we had a customer who was looking at building and buying a GPU cluster for building large language models. And so they went to NVIDIA, and NVIDIA basically said, here is the latest portfolio we have. And it was $6.5 million. And then they came to us and said, here's the problem we're trying to solve. And we said, sure, you can buy all of the latest and greatest gear, but you do realize that you have a problem that doesn't need the latest and greatest, right?
That's so important, because I spent so much of my career with very high-end databases, particularly with Oracle RAC, and Oracle Real Application Clusters, and I so often made the exact same argument to people that they didn't need all of that power, that they needed an architecture that was much more suited for what they were trying to do, once I understood what they were trying to do. So I had to interrupt you there, because we have such a parallel in that regard.
Yeah, and so the customer went to NVIDIA, $6.5 million, and then they asked us to look at it. And we said, look, we will, at the tail end, we will use the same GPUs as NVIDIA, but we will increase the efficiency along the line, network and storage. And so we did that for $3.5 million for them. And so the biggest challenge we had was to explain to their management why we were so much lower than NVIDIA
They didn't believe you. They were
Right.
They were suspecting that you were doing something that was less valuable when they just simply should have opened their minds initially, which I'm sure they did eventually, to the better solution.
Right. And the funny thing,
yeah, a lot of people associate paying more with getting more.
Yeah, absolutely.
Right. And so the funny thing is if the customer had gone straight to us for $3.5 million, they would probably have complained that it was too much money, right? And so nowadays I actually tell our customers, go to NVIDIA, because then you set, a high watermark for the pricing. And then whatever we ask for, we will fit way better in their budget.
That's a great strategy. Get them to pump it up.
We're running out of time, but there's a couple of questions I really want to get in here before we shut this off. I listened to I saw your podcast the other day, the Tech Field Day podcast, and it starts out with an ominous warning, and it's one that reminds me of something from the past. You mentioned irrational exuberance. That's particularly interesting to me because the Federal Reserve Chairman, Alan Greenspan, warned the U.S. Congress about irrational exuberance. He used that exact term, back in 2007 regarding stock derivatives, and particularly the housing market. I'll share that link to your podcast when we actually publish or we post this particular episode on the Don Sullivan Show website. But the vast audience of the Don Sullivan Show wants to know, what did you really mean by irrational exuberance in that case?
Right. The problem is that AI's biggest enemy is hype. So if you look at the history of AI, there were 2 AI winters. And so what's an AI winter? An AI winter is a situation where there were advancements in AI, but everybody was pumping up AI so much that people had certain expectations and were disappointed. And the disappointment turned into less investments, less use of the technology, to the point where it came to a standstill. And so what we're saying here today is, when large language models came out about 2 years ago, a lot of people were saying, oh, this is easy to use, right? You put in a prompt, as opposed to Google search, where in the past you had to limit the amount of words, otherwise you would get a bad answer. Now you pretty much can write a book and you would get an answer. And people were also starting to expect a lot more, right? Oh, I can do a large language model to do, to write a book and do cooking and self-driving cars. And so there was a kind of euphoric approach 2 years ago where people were saying,
exuberance.
Where people were saying, hey, this is really get out of control. And even today, my number one enemy really to my business is hype. It's a vendor saying, buy my stuff, because with my stuff, you can build large clusters like, name your big AI cluster. In reality, is that most of these vendors are just promoting hardware, right? They don't sell you the secret sauce. They don't sell you the efficiency. They're just selling you a story where you would just buy their hardware. You would be surprised how many customers we have who end up buying GPUs and then stopped there. And when I say a GPU is not a server with a GPU, but just physical GPUs, it's almost like it's an investment, which, believe me, it is not. And that's all hype, right? It's
so I was going to end this podcast by asking you what scares you the most, but I think you've already answered that. The hype. Is that what scares you the most? The overhype, the irrational exuberance.
Yeah, it's a few things, right? So first of all, from a consumer perspective, I think the outcome of an AI solution is that you take the default answer as the correct one. I think from a user and a consumption perspective, that's scary, right? That people don't take an answer and analyze it. When you and I have a conversation and I say something, there is something in you that will say, I need to validate this information, right? It seems like people consume AI without that reflex saying, is this really correct? So that's definitely scares me from
internet at large.
Right. And you can see that with, there's all these AI code editors, right? So nowadays you can go into a code editor, you type in some words and say, write me a program that does this and this and this. People just plainly copy and paste that in the program and then call themselves developers. That scares me because you're using AI, but you as a human, you forget to do your thing, which is to reason and figure out if the answer is correct. You should look at AI as a tool to augment our abilities, not to replace our abilities.
Well, Frederic, on that note of incredibly sage wisdom, I am going to thank you for having joined the Don Sullivan Show, and the vast audience of the Don Sullivan Show thanks you in absentia as well. I'm going to invite you to come back on every 3 to 6 months. Maybe we'll have you and Gina and some others on together to have some panel discussions as well as we move along. I hope you become a friend to the show. I know that HighFens is going to eventually become a major player in the more sage and wise aspects of the development of AI and the future of quantum computing as well. Again, we'll invite you on again, and I hope once you see this posted, you don't get turned off too much, and people don't think that we're really going to have Eddie Van Halen back on to. But Frederic Van Haren, thank you so much for joining us. And you got anything left to mention before we end this out?
I just want to thank both of you for having me on. This is a great conversation. I'm looking forward to continue the conversation.
And we will. Steve?
Absolutely. Thank you so much, Frederic. And I'd like to thank today's sponsors. Today's episode is brought to you by License Fortress, the industry's first and only software asset management firm to offer both a financial and legal guarantee at its highest level of service, whether it's Oracle, Microsoft, or VMware. License Fortress helps organizations stay compliant, avoid audits, and save money. Learn more at licensefortress.com. And also, please support our producer by visiting axtinc.com. That's AXTINK.com. Subscribe to his YouTube channel and help support his efforts to create humorous animation, as well as run our website, all while researching a cure for baldness.
And it still isn't going to happen. Don. We know that. And thank you, audience, again. We'll be back again with a broadcast very soon. And I want to remind you all as we leave out, as we sign out here, that all at-bats are situational, and see you next time.